So good evening once again. So let me just restate what I said a while ago. You have two projects for this subject. One project is the use of machine learning tools, okay, and combined with another machine learning tool. Okay, so you'll have a comparison between either two machine learning tools or a machine learning tool and a regular statistical procedure, of course, both using R. So that's the project that's due for next Friday. And the other project is due next Friday, will be optimization, just like what we're doing. So you're going to have a portfolio of stocks, two stocks, 3 stocks, and 5 stocks, and then create a minimum variance and the maximum return portfolio for that. Of course, all using R. And then you're supposed to also create an efficient frontier. Okay. So later on, I'm going to illustrate to you how to create an efficient frontier. Do you all know how to download stocks from Yahoo Finance? Directly, guys, via Yahoo Finance?
Not yet.
Yeah. Not yet? Okay, so some of you know. I'll just teach you how to do it. Okay, and then do you know how to create an efficient frontier? Silence means hello. Ronnie, do you know how to create an efficient frontier?
No, sir.
No.
No.
I remember you taught me before. I downloaded from Yahoo the stock price.
Yeah, but just the downloading. But how about the creation of a frontier, an efficient frontier?
Don't understand.
yet.
Oh, okay, good. Okay, good. So, okay, might as well discuss that later on because that's related to your project, and that's a skill also that any finance student or finance professional should know. Of course, we can do that in R, but what I'm going to do is discuss it in Excel, and I'll leave it up to you to research on how to create that in R. Okay, so that's the point where you have to, on your own, do some research on how to create an efficient frontier using, for example, F portfolio. It's a package in R. Okay. All right. So those are the two requirements for our subject. So as I said, you can choose data sets here in Kaggle. These are free data sets. Okay, for example, these are new trending data sets, I think. Death caused by country. Okay, so as much as possible, guys, choose something that's related to finance or economics. But it's okay, guys, if you're going to do a machine learning on, let's say, a trending topic, let's say COVID. If you would like to have a study of about COVID, there are some data set that's free that you can download, and so you can, for example, do a modeling about COVID. Okay, so for example, this one. Let's see if I click this one, COVID-19 weekly trends. Okay, this is free for download. And okay, so what are the variables here? So you can download this. What are the variables here? So we have the country, 47 countries, cases in the last 7 days. Okay, cases. So these are cases in the past 7 days, etc. Okay, so if you're interested in this one, but be sure, guys, that when you create a model, it should have some sense. Okay, you cannot just create a model without any insight at all. Okay, and then it's not just running the model, you have to explain. Okay, so it's like a procedural paper. You are explaining as you go along the step, you're explaining what you're doing. And then of course, at the end, you have to analyze. You have to give insights on what you have garnered or what you have gained from analyzing the data. Okay, so it's pretty much it's like laissez-faire. I'm giving you the leeway. I'm not giving you an outline. Okay, so of course you have to write there the objectives of your study. What is it for? What's the purpose? Okay, and define, of course, the variables that you're using. Just like a normal paper. And then at the end, of course, you have to have a conclusion about it, and a discussion of your analysis. Okay. Do you think next Friday will be fine with you guys, or would you rather that both papers will be submitted both 2 weeks from now?
Yes. 2 weeks from now.
Okay. Yes. I think it's fair. It's just fair that both should be submitted 2 weeks from now. Okay. I'm sorry, guys. I refrained from really burdening you with this before, but on hindsight, I think I should have already given this to you before. But because of really the situation we're in now, some of you, I experienced I experienced sickness also, and I don't know, some of you maybe. Okay, so I think that's okay. So the paper will be due 4 plus 18, right? 18 of February. Okay, deadline is 6 p.m. Okay, so please give me time to check the work. If you have any questions, please feel free to PM me, okay? To message me. Okay, so let's proceed now with our lesson. We'll finish the R markdown file which we were working on last time. So kindly open that R file that we were. By the way, guys, there's another site where you can get data. Let's see. That's UCI. Okay, I don't know if you're familiar with UCI dataset repository. Okay, so Kaggle and then UCI. Okay, so this one also has a lot of data sets that you have to choose properly. There. So some data sets for classification, regression. Okay, and there's a summary here. So this data on abalone is a multivariate data. It's used for classification. What are the variables here? Categorical, integer, real. 4,177 observations and 1995 data set. Okay, so you have a lot of sources, that you can have. Of course, guys, for the portfolio optimization, just use quant mode and download the stock prices. Okay, but let me create a spreadsheet. Okay, spreadsheet in Google Drive. Okay, so that there will be no repetition of stocks. Okay, you choose 5 stocks. Okay, from that you'll choose 2 and then 3 and then the 5. Okay, so no one is allowed to repeat a particular stock. So there are thousands of stocks in Yahoo Finance, and I'm sure there will be no problem choosing stocks. But when you choose, guys, choose along a particular industry. Okay, so you do some research on, for example, food industry. So maybe you can choose stocks about food, okay, or about let's say technology, etc. So choose something that will be quite, maybe a combination, maybe, or let's make it maybe 6 stocks, 3 coming from different industries. Okay, so that you can have a mixture of different industries. And then what's the task there again? Portfolio optimization. Okay, so let's see my chat. Yeah, love, yes, both 2 weeks from now. Yes, both 2 weeks from now. Okay, all right. So this is another source of data, UCI machine learning. Okay, you can navigate through this and look at different different data. And there are other sources, of course. There are other sites that provide data sets. Even R, guys, even R. So let's open R. In R, most of the packages have I've been having problems with R since this morning. My R has not been working well. Okay, so for example, there's a package called datasets. Let's go to packages here. And see, datasets. Okay. I forgot the name of the package, but I think it's data sets. There's this Datarium. Okay, it's a data bank for statistical analysis and visualization. Let's see, what's Datarium all about? Datarium. I know there's a package in R that contains several data sets, and some packages also. Most of the packages, I mean, have come with data sets. So I've been having some problems with my R. It has been processing very slow. Okay, that's a problem with my R since this morning. I had a class and then so you see this function, this one. I asked help for this function around 2 o'clock a while ago, and it just appeared now. Imagine 4 hours before it gave its output. Okay. Anyway, guys, you can Google it, guys, and look for. I'm not sure if it's data sets. Here, Datarium. Okay, so here are data sets for not so many here. There are other data set. There are other packages that contain a lot of data. So this is anxiety. This is used for ANOVA, mostly for ANOVA here. Okay, mostly for ANOVA. Okay, are there any questions about the project, guys?
In the chat box, sir.
Sorry, sister. Okay. No, you don't have to submit a printed copy. Just the soft copy. Okay. So of course you have to submit the RMD file and the HTML file. You know this one, guys, when you knit this, okay, when we knit this, for example, let me go to, let me see. I'm looking for a, okay, have you tried knitting your R, guys? For example, this one. Let me open this. All right, and then you can knit this here. Knit. You can knit it to Word, PDF, or HTML. So I prefer, guys, that you knit it to PDF or to Word, because when you knit it to Word, to PDF or Word, then it will create a Word file and or a PDF file. Okay, so you submit the RMD file and the knitted file. Let me knit this, for example. Let me knit this to Word. So it will generate a Word file and it will save in my directory. Okay, or you can knit it via HTML. Okay, and then it will create an HTML file. So you're supposed to submit the RMD file and the HTML file. The HTML file or Word file or PDF file, it's like it will generate a print out of your code and of course your work, okay, even the results. Okay, so that's another aspect of RMD. I think I have not discussed this with you, but guys, you do some reading on that. The R Markdown file has the capability to be knitted to PDF or to Word. In fact, RMD file, this types of file is being used to write books already, because you can write books out of this, out of another package, for example, Book Down. Okay, but it uses the RMD file. Okay, did that answer your question, Ronnie?
No, sir.
Sorry.
That's me, sir.
Sorry, it's Robbie, no? Robbie, clear?
Yes, sir.
Okay, sige. Any other questions, guys? Feel free, guys, to communicate with me, okay? So this will be our last day of classes, no? So it will take off no classes next week to give you time to work on your project. Okay, so let's go back, guys, to our file, to our markdown file, the one we were working on last time. We will not go through through all the codes again because it's too long. We will just select some portions here. Of course, let's engage the quant mode package. Okay, wait, it's still, yeah, I forgot that I okay. So let's first require the quant mode package. And then there are some other packages that we will be, okay. Now I'm, This is knitting, okay? All right. Okay, it was not able to knit because there was a problem. Okay, never mind. Please try knitting. Maybe start with a small file. Okay, let me just illustrate that for purposes of just to make sure that you. I've been having problems with my R. Okay, so just to illustrate, let's open a new R Markdown file. Okay, R Markdown. So let's just put here trial. So it can be an HTML file, a PDF file, but if you're choosing PDF, you will have to download this MIC text on Windows. Okay, you have to download MIC this add-ins MIC text from it's a free download. Okay, or you can print Word, but let me just choose HTML. Okay, trial. Okay. So it will open a new R Markdown file. Okay, so this is the not yet. Yeah, is it? Yeah, trial. So this is the default. Okay, if you run this, okay, so this is from the package. It says here HTML document. Okay, and then let's say plot pressure. Okay. All right. Echo is equal to false here. Okay, here. Echo is equal to wait, where's echo is equal to false? Echo is equal to true. Note that echo is equal to false parameter was added to the code chunk to prevent printing of the R code that generated the plot. Okay, for the plot here. R pressure echo is equal to false. Okay, which means that it will not print this code, the plot the plot pressure. Okay, so just a simple example. Let's try to knit this. Knit to HTML. Okay, I said you can knit to PDF. It will generate a copy of PDF or to Word. Okay, knit to HTML. Okay, so where will I save it? I'll just save it here in FIN601M. Okay, so this is trial. Save. So there it's knitting now. Okay, so it now has an output. Okay, so that's trial.html. We can publish this. Publish. So take a look at this one, guys. So this is the output in HTML. So you see, it's like a document. It's like a document. It's not, it's nicely written, guys. So here you have the title, trial. Okay, so this is what we call the metadata, author, date, and this is the text, R markdown. Okay, the double hashtag here, this is actually for outlining. So double hashtag, if it's one hashtag, it means a bigger, it means just like the first of the outline. So I suggest, guys, that you read a bit on R markdown, because truth be told, you can use R markdown to create your report in any subject. Okay, you can use this, especially if it's a project that will require some computation or will require some data analysis. It's a very convenient way for plotting, for example, this one, right? And you see, we place here at include here. If you recall this one, it says here, okay, echo is equal to false, okay. So this is the name of this code chunk, pressure. And especially if you have a long big data, a long chunk, by giving a name to your, we didn't discuss this, guys, but I wish that you would also read up on R markdown. We were focusing more on the applications, but not so much on the document making. But take a look at this, for example. Why did we put here pressure? Because it will serve as a like an index. So for example, I go here to chunk 1. Okay, it will go to the first chunk. And if you have several chunks, it's very convenient. Just look. So chunk 1, chunk 2, here chunk 3, and then it automatically brings you to the third chunk. Okay. So for example, in our discussion, we never placed index here. Okay, so it's really good practice, but since our focus was more on the application of statistical tools, so here you can see only generic naming. Okay, we didn't put names to our chunk. Okay, so let me once again go here. So this is the HTML plot. Okay, and then this has been saved as an HTML, so you can send this to me, and I will easily see your output. Okay, so it will be easier for me to read your output here in the knitted document as compared to the R markdown. Okay, guys, is the instructions clear on why I'm requiring you to submit a knitted file? So the knitted file can be in the form of HTML, or it can be in the form of Word or PDF. Okay, if you want to print it in PDF, then you have to download that document that make text. Okay, I think I did that before, so let me see. Let me see this trial. Let me print this. Let me knit this to PDF. So here it's knitting. Okay, there. So trial.knit.markdown. Okay, output created, trial PDF. Okay. So here is my PDF file. So let me just quite similar to the Okay, and you can do that also you can knit also your document in Word file. Okay, so one very good way to generate your output. So guys, when you're creating your file, make sure that you, for example, let me just distinguish, okay? So there will be a difference between, for example, if I just put one hashtag here. Let's try to knit this again. This time, let's try to knit in Word. So I gave examples on knitting to HTML, knitting to, so this is knit.markdown file, and then it's converting it into a Word file, and then it will generate that Word file. So what's the difference if it's just one hashtag, or if it's two hashtags, if it's three hashtags? You can actually create outlines for your output. Okay. This now is a Word file, guys. See? And you notice this one, guys, are marked down. This has one hashtag. Okay. Including plots has two hashtags. Okay. You notice that the R markdown is bigger. Okay. In fact, I could have used A or 8.1 here for the outlining. You can use the R markdown to outline your output. Okay, and then I can save this. Okay, I can save this document. Okay. Any questions, class? Ronnie, any questions? Robbie, Love, sister?
None so far, sir.
None so far. Okay, so is this the first time you have heard of R Markdown being used to print the output in a PDF or HTML or Word file? Sister, first time?
Yes.
Yeah, okay. So, but I suggest that you do some readings on on R Markdown, because R Markdown is powerful. As I said, we did not discuss that before because we were more on looking at the application. But when you're now generating your reports, okay, you can use our Markdown file, and then you can print a report out of this. And the report is good. It's in good format. Okay, and of course, as I said, you can put here, for example, here I'm going to put, for example, introduction. Okay. So when I write my report, it's already in outline form. Okay, so for example, this one, okay. So whatever outline. Okay, so for example, one. It's only an example. Okay, so for example, A. Okay, so when we need this, I just need to HTML. So when you need a document, it will run here. Okay, there. You see, guys? One hashtag, it's the main outline, and then A here, you have smaller. And if it's three, guys, it's smaller. Okay, there are many sources, guys, in the internet on how to make use of the R Markdown to generate a report. Okay, so I hope that's clear, guys. I won't bother so much with that anymore. It's your master students, and you can, of course, on your own, you can on your own learn these things. I just show you the way, and it's up to you guys to open the door and explore the house of R Markdown. Okay, so quickly, guys, let's go back here. Let me just. delete this. Okay. So let me just invite you to, again, we'll use this name, tickers. Okay, so kindly go to number 56, I think thereabouts. We may have different positions of our code. So let's again create this. Let me first delete everything here, okay? So I'll start fresh. Okay. So I'm going to run this stickers, control enter. Okay, so we now have this sticker because we're going to use this once again to download the prices. And then let's go to row number. We'll not run again the others because we have discussed that. We just need okay, so we go here to two first. First, let's run library, the add into quant mode. Okay, let's run this. Okay, and then once we have run that, we can now create a price frame. Okay, a price frame, guys, is a collection of your stocks, but you should have already an existing one. Okay, so we have here make price frame. You have Apple, Google, Microsoft. So this is actually from our tickers, right? From our tickers. Okay, let me just check. Control C. Okay. And then let me check. I haven't tried this before. If I use stickers, okay, make price frame tickers from to and prefer the adjusted price. So let's see if we can create a price frame out of that. So remember, this is from QMAU. Let me write the namespace there so that we know where this is coming from. Okay, let's run this. Okay, so this is wrong, guys. Why can't we create this? We can't create this because there are still no objects for the stocks. Let me replace it with this one. So I replaced it with the list of Apple, Google, etc. Let's see if we can run this. Okay, why is this still not running? Can anyone please tell me? Why is there an error here? Okay, there's an error here because you don't have this object yet, Apple, Google, Microsoft, etc. So this function requires that you already have these objects. You should have your Apple, Google, Microsoft, etc. So we need to get these symbols first. Okay, so before I go here, we have to run this one. Okay, we have to run this one first. So get symbols, if you recall, guys, get symbols from quant mode package is used to download data. So let's download data. What data? Tickers. So this one, Apple, Google, okay. And we set the date from December 31, 2016 to December 31, 2021. Daily data, auto.assign is equal to true, which means that quant mode will give automatically the names to our objects. It will give a name to the objects. So let's run this. Run. Okay, so objects here should be created, Apple, Microsoft, etc. We should have those objects. So let's wait for it to run. Then once we have those objects, then we can now create a price frame out of that. If you have any questions, guys, please feel free to ask. Okay. There. Okay. So we now have the the X there, Apple, Amazon, Facebook, Google. And notice it's now being reflected in the global environment. So we now have these XTS objects, Apple, Amazon, Facebook, Google. Okay. All right. Then since these objects are now available, we can now run this. We can now create the data frame. This data frame will create one data frame called PF, okay, and it will include prices from, so it's price. It will include the prices, the whole of it, because it says from 2016 12/31 to 12/31/2021. So it's the whole data set. We can, of course, we can subset this. For example, we just want 1 year, so from and to, and then we prefer to get the adjusted price. Okay, so let's run this and let's view the object PF. If I run this, okay, so we now have PF here, and it's also an extensible time series. Okay, by extensible time series, you notice that the index are the dates. Okay. If it's a data frame only, then the index will just be numbers 1, 2, 3, 4, 5. Okay, and then the date will be another column. So before, when these packages were not yet available, it was quite hard to do time series with data frames because the dates were as one row here. Okay, so sometimes when you do modeling with data frames, especially when it's time series, it's really quite difficult. You have to adjust. You have to do some adjustments. Okay, so this is the PF object. Now, but what we're interested in more is the returns. Okay, so in fact, we could have dispensed with this one. So we use PF. So that's the same as make price frame. Okay, the same. Okay, and then instead of identifying the list, let's see if this will work. Why don't I just use the name tickers? Okay, and the function is PF. This is also price frame. Okay, let me just let me call it also PF, and then run this. Adjusted price also. Okay, so what happened from? Okay, the problem here is that it does not read GSPC. Okay, Right. So when we use stickers, it does not read GSPC. So let's see what stickers here. Let's take a look at the stickers. What was our tickers here? But we need this because GSPC is the symbol for GSPC is caret. It has to include caret. Okay, so we're having a problem there. So anyway, guys, I haven't deciphered, guys, why this is not running, but it ran a while ago when we used when we spelled out the names. Okay, so since we're not able to run it using tickers, let's just revert to this one. I'll change it again with the names. Okay. Okay, so let's run this again. Okay, then it's okay. It's run. Okay, let me pause for a while. Any questions? Any questions? Clear so far? Okay, no questions. All right. Now, what we really need is the return frame. When we do portfolio optimization, we model the returns of the stock. So please remember, guys, do not model the prices. Okay, rather model the returns. Okay, so let's run this. Let's create an object called RF, and then let's use the make return frame, or you can use RF here. It's the same, make return or RF. So let's run this. Okay, let's take a look at our code. Same period, adjusted also, and then we use continuous returns, which is the log of the value at time t divided by the log of the value at time t minus 1. And a.omit is equal to true. Why is this is equal to true? Because we already have given names to our object. I'm sorry, na.omit is equal to true, which means you delete, we're commanding quant mode to delete those that have missing values. Okay, and okay, but usually there are no missing values there. Okay, so guys, this is just a quick review of what we discussed so far, and also we need to run this because we need this data to do our portfolio optimization. Okay, so we have here the RF, the return frame data. This is also an XTS object, but you notice there's a row that has NA. Okay, so we're going to remove that. Okay, so here our RF will be RF. -1 means the first row will be removed. First row, or this is the same as this one, and then comma. First row, and then all the columns, or you can just write here -1, which means remove the first row. Okay, so let's remove the first row and then view again our return frame. Okay. All right. So we have this, guys. These are returns. Okay. These are log returns of our data set. Okay. So let's now go to our portfolio. Okay. So this is where really your project starts. Of course, you have to download the data first and get the returns. Okay. So what we did last time was just to have a 2-asset portfolio. So we're creating an object called port1. This is portfolio 1. And then we're using the RF, the return frame object, and then just get the first 2 columns. So the blank here means all the rows, and then just columns 1 to 2. Okay, so if I highlight this, 1 to 2 means Apple and Google. So we're just subsetting this. Where if you want, for example, Apple and Tesla, then it should be 1, 8. Okay, because you might be doing that in your paper. So, for example, it's Apple and Tesla. So make this C, combine Apple and Tesla. Sorry, 8. Okay, so if what you want is Apple and Tesla. Okay, but for our purposes now, let's just use Apple and Microsoft. Okay, so let's what are we trying to do? We're trying to create a portfolio for Apple and Google, and we're going to compare the results, the returns of the different portfolios under different conditions. Okay, when we say portfolio, guys, from your modern portfolio theory, based on Harry Markovich, he said that what's the purpose of a portfolio? The purpose of the portfolio is to create a how should I say that? Is to one of the most important purposes of the portfolio is to minimize your risk. So that's mean variance, minimum variance, which variance is a measure of the riskiness of the portfolio. Okay, so we create an object called port1, and it contains only the returns of Google and Apple and Google. Take note, guys, we're using the returns. Okay, we're not modeling the prices, not the prices of Apple and Google. Okay, so let me run this. So just run the head for 6. Okay, so it's Apple and Google. Okay, so we're correct. All right. Now let's create a portfolio. When you say create a portfolio, we have to know what weight are we giving to each stock. So we have a 2-asset portfolio here, and our first example will be just create a balanced, equally weighted portfolio. So which means 50% each. Okay. So we're going to use performance analytics. This is a package. Okay, make sure that you have access this. So that should be library performance there, performance analytics, and later portfolio analytics. Okay, so let's access that. And then in performance analytics, okay, we can easily compute for the return portfolio. Now, take note, guys, that these are returns. Okay, where's our port1? Let me close this. Okay, I don't think I viewed it. Okay, let me view that view port1. So these are port1. It contains 1,257 returns. Okay. So when we create a portfolio, let's say it's 50-50. So we'll be able to compute the returns for each daily returns. So how do you compute for that? So it's simply 50% times the Apple plus 50% times the Google returns. So that will give you the portfolio returns for this specific day. And since there are 1,256 to 1,257 observations or periods or days, then we will have 1,257 portfolio returns. Okay, for each day. Okay, so we're going to use this function return that portfolio. And what it will do is it will compute based on 50-50% the return of our object port 1. Okay, and we're creating an object out of that. We call it port 1 ret. And let's view it. So let's run this. You'll see that when this object port 1 ret is shown here, you'll have a time series. You'll have a not time series. You'll have time series where there you'll have the portfolio returns. There only one, because the 50-50% was computed for both Apple and Microsoft. So for our portfolio on January 4 had a portfolio return of this amount. Okay. All right. Then maybe let's change the name, because the name here is portfolio that return. So let's call it. Let's call it port 50. Then maybe port 50, which means 50%. Port 50 underscore ret. We'll call that portfolio 50 underscore ret. So it will change the column name because it's currently portfolio that returns. That was a default. So let's just change it to port 50 ret. Okay, so when we access this again, the portfolio port ret 1, so the name has changed. Okay, all right. So that's one way to look at your portfolio. Now another way is, of course, guys, you can compute for the average. Okay, so let's see. Average of port ret 1, port 1 ret, that's our object. Okay, port 1, portfolio 1 ret. Sorry. I thought it was Excel. Port 1 ret. Okay, so the average return for our portfolio for this period, okay, it's computing. So it's getting all of this, and getting the average. Okay, so average of that. It's taking some time. Okay, then last time also, let's quickly do this. This is just a review. We did some rebalancing. Okay, what's the difference between the first model and this one? Oops, port 1. Sorry. That's why it should have been mean port 1. Okay. Port 1. Always use the IntelliSense, okay, so that you don't have wrong spelling. Okay. So that's 1.0 0.12%, okay, 0.12%, that's average daily returns. If we want to convert that to annual, we multiply it by 252 because there are 252 trading days in a year. Okay, so that this will be the annual returns. Okay, Control Enter. So that's 32% for this portfolio. Okay, we'll see that again later. Okay, so how about creating a portfolio that's rebalancing? Okay, when you say rebalancing, it will change the weights. It will not be 50%, 50% all throughout the life of the portfolio. It will try to find weights that will maximize your returns and at the same time try to come up with a lower standard deviation or lower risk. You can read on Investopedia the purpose of rebalancing, but that's the main reason there. Okay, of course, you normally don't do rebalancing frequently because it's expensive, because it involves buying and selling of your stock. And as you know, it has transaction costs, there are tax implications. So sometimes others would do rebalancing every 6 months. It's already quite a lot if you do it monthly. Okay, for some it's yearly. Okay, so we create this object, port 1 ret. And the other one was port 1 ret. This one is port 1 rebalance. Okay, rebalance. And then we also use this function return that portfolio. Same port 1. Port 1 is the object containing the returns of Apple and Google. So we're going to use the same object. Also again 50-50, okay, but rebalance on months. So for the first month, it will be 50-50, but come the second month, okay, there will be a change. And then also come the third month, it will again rebalance, etc. Okay, so let's call this port rebal. Let's also change the name. Let's make it consistent. Here it's port 50 ret. So let's call this also port 50. To make it more intuitive. Port 50 rebalance that ret. Okay. Port 50 rebalance that ret. So quite similar to the other one. Okay, let's not use that. Okay, let's use underscore. Okay, we want to have the names quite similar because when we create a table, annualized table, we want it to be intuitive as far as the naming is concerned. Okay, so that's the name of our variable. Okay, so what do we have here? This is rebalancing. If we compare this with port 1 ret, okay, you notice that for the first month, they're the same. Negative 7.67, 7.04, 7.67, 7.04. It will be the same because for the first month, it will be both 50%. But come February 1 here, in our rebalance, the return is 2.89. However, in our port 1 ret, in our port 50, February 1 is 2.93. So they're different. For the first 30 days, it will be the same since there's no rebalancing yet. But for start February 1, since the rebalancing is monthly, then they will be different. Okay. Now what we want to do is to create an object where we'll be combining. Okay, we'll be combining these two objects. The first object is port ret 1. Second object is portrait rebalance. Okay, we're going to column bind them, put them side by side in one column. And then let's let's create the name, call names of all port. So all portrait. So let's call the column of this non-rebalance, and then the other one is monthly rebalance, and then we'll be creating table.annualized returns. Okay, so this one, this is also from performance analytics. Okay, there. So there are many functionalities of performance analytics. Okay, so it will create annualized returns, and then it will use this all port one rep, which contains the port one rep, which are the portfolio returns for the 50/50 table, for the 50/50 portfolio, and this one for the rebalance portfolio. So as you see here, guys, it's also from performance analytics. Okay, so we need to provide the risk-free rate. So let's assume the risk-free rate is at 10%. And then since our data is daily, we have to divide the 10%, which is annual data, by 252 to convert it into daily data. Why do we have to do this? Because our returns, all our returns are daily returns. So we have to convert our risk-free rate into a daily return also. So running this, okay, so we can, here we see the comparison of the two. So let's run this again. Okay, so in terms of annualized returns, our rebalanced portfolio performed better than the one that was not rebalanced. The risk also of our rebalance is lower, 2623. This is 2677. Okay, and in order to especially in case if there's a conflict between the returns and the standard deviation. For example, for the returns, the monthly rebalance is better, but for the standard deviation, the non-rebalance is better. So how do we resolve that? Different choices, different output, different better outputs for these two categories. Okay, that's why we use the annualized Sharpe ratio, which is just your annualized return minus your risk-free rate divided by the standard deviation. So this is standardized returns. Okay, and it turns out that the monthly rebalance is higher. So the higher the Sharpe ratio, the better. Okay, let's just check if indeed that was the formula that was used. So let me check this. This is your annualized return, Control C, Control V. And then let's subtract the risk-free rate. Annual risk-free rate is 0.1. Then we divide it by the annualized standard deviation. Control C, Control V, just to check, guys, if indeed, unless they were using a different measure for 0.8867. Okay, so I think they're using another an adjusted formula for the Sharpe ratio. But the Sharpe ratio, guys, the formula for that is your annualized return minus your risk-free rate divided by your standard deviation. 332626. Okay. All right. I'm getting a different answer, which means that they computed this differently. Okay, and then also this. Sorry guys for having to repeat this. All right. So here we have here a side-by-side comparison between the rebalance and not rebalance, and we can see that the chart for the monthly rebalancing is better. Okay, this one, you see the red one, that's the monthly rebalance. So towards the end, this is cumulative return. So it's adding the returns over time. So you see that the red one, which is your monthly rebalance, is better than your non-rebalance, which we saw in our graph here. 32.87% versus 33.26 in our table here. Okay, now let's go to now for this first two portfolios, we did not create any optimization. Okay, so in your paper, guys, you can do that. First, come up with a 50-50, and then come up with a rebalancing. Okay, now we go to creating portfolios with optimization. So the next, all the rest, guys, are with optimization. So we started this last time, and we said that we'll be using the portfolio analytics package. So if you haven't required that, so do that now. Library portfolio portfolio analytics. Okay, please run that. I have run that already, so I won't run it again. Okay. So there are certain steps here. Number one, of course, define your portfolio and put there the specifications. Add the constraints that forms part of your specification. Also add the objective, and then run the optimization, and then get the weights, and then prepare tables and reports. Okay, so we'll be using the portfolio analytics. Okay. All right, we'll be using the same object port one. Port one contains the returns of Apple and Google. This will still be subjected to optimization so that we can compare it with the first two outputs that we had. Okay, so we define the specification, and the code there is portfolio.spec. Okay. All right. So firstly, we assign the assets. What are the assets that we're going to use? So we call it the object we call port spec. We call it port spec 1. And remember, I told you last week that this is like a receptacle, and this is like a container where you put your specifications, your constraints, your objectives. Okay, it's like a catch-all basin. Okay, first we identified the assets. Our assets is let's use the column names of port 1, so that will be Apple and Google. Okay, so let's run this. When we run this, we have this output. Okay, the formula is portfolio.spec. Okay, and it has two elements, the asset names Apple and Google. If you view this, if you view our object, view port spec 1, port spec 1, okay, and it will so where's port spec 1? Did it run?
May error po, sir.
Error? O, sige. Wait. Let me stop share. Sister, could you? I'll make you all. Okay, hold on. My computer is again. I'll make you all co-hosts so that if you, in case you want to share your screen. Okay, sister, you may wish to share your screen. Okay, let's see. Error in portfolio.spec. Okay, sister, have you run? Kindly go up. Okay, go up. I think you haven't run there. No. Okay, just run the. No first, no. Just run the library, not the whole one. Just run the library because we installed that already last time, right? Okay, so go back again to your, I think it has already been installed. Okay, then go back again. Run that 343 to 345. Run the whole code chunk, please. There, okay? So that's your, thank you, sister.
Thank you, sir.
Okay, so that's your port spec 1. Okay, so what does it consist of? It consists of, okay, assets. Okay, we have Apple and Google. Okay, it does not have constraint yet because we haven't placed the constraint. It does not have objectives yet. So we keep on putting items here, components in our portfolio specification. And then once we're done, what we do is to run it already and optimize it. Okay, so let's go back. So we now have our port spec 1. We can add constraints to it. And we said we can use full investments, which means that the weight of the asset should be 100%. Or sometimes there will be problems with this. It will not generate an output. So we can relax this constraint a bit by using the weight sum so that the sum of the weights could be between 99% and 101%. For the box, it's used for the weight, individual weights of the assets. So you can put a minimum and a maximum for the weights. And then long only means that there will be no short sales, no shorting, which means that the weights should all be positive, cannot be negative. Okay, so since we have already our port spec object, we will add constraints to it. Okay, so here I have put in comment form the constraint type is equal to full investment. But if you recall, we did this last time, but it returned an error term. Okay, it could not find a solution where the sum of the weights is 100%. So we're going to use this weight sum, type is equal to weight sum, or we will relax our constraint a bit. 99% can be, or 101% can be. Okay, so that's a more, let's say, a relaxed constraint. Okay, and then only positive weights, and then for the weights, nothing to exceed 70%. Okay, the problem if you don't put this, the maximum, is that if you're maximizing the returns, it will give 100% of your allocation to your asset that has the highest return. And that will defeat the purpose of optimization. It will defeat the purpose of diversification. If you don't put this constraint that, for example, the maximum 70%, then as I said, it will generate a portfolio, especially if you're looking for a portfolio that maximizes the returns. It will generate a portfolio where 100% of your funds is placed in the asset that has the highest returns. All right, so let's run this. Okay, and then if we take a look at port spec once again, so the constraint and the objectives are still 0. It has not yet been added. Okay, so let's continue. And then we have the objective. So we have first we identified the assets, then we identified the constraint, and then we identified the objective. The objective can be minimization, so you minimize the risk, or it can be maximization, you maximize the returns, or it can be both. Okay, it can be a combination of maximization and minimization. Okay, so for our first model in optimization, we're going to minimize the variance. So let's create this this object port min var, minimum variance. Okay, and we're passing on all the elements of port spec 1 to this object. Okay, why are we doing this? Because we'll have another objective, which is maximizing returns. So we will still need this port spec 1. So this port spec 1 does not yet have any objective. So we're going to preserve this port spec 1 so that later on, when we create now a portfolio where we're maximizing returns, okay, then we still have this port spec 1. Okay, so we're passing whatever's in port spec 1, we're passing it also to port min var. So it's just like a replica, okay, a replica. However, when we go to the next one, port min var now will contain an objective. So the objective is coming from portfolio, port min var. Okay. Take note, port min var is the same as port spec 1. And since we're minimizing the risk, the type here is risk, and then the name is standard deviation. Okay, and then let's view this. Let's see. Let's run this. Okay, so we have now another object, port min var. Okay, port min var contains port spec 1. Okay, you have the assets, but it now contains also the constraints and the objectives. So the constraints, as you can see here, isn't it that we added the weight sum constraints, right? Minimum of 99% and maximum of 101%. We also have this box constraint. So let's see if this will box the minimum weight constraint. Let's try to see if this will there. Okay. So minimum sum 0.99, maximum sum. So whatever we place there in our constraint, it's recorded here. Okay. So the call is this is the formula. Okay, and then this is another constraint. So all the elements we have put in our receptacle, in our container, will be contained here. We also have objectives here. So the objective is, let me see if I can. Okay. Objective, it's just a list of one length. Okay, we can we can explode this. Okay, so that's now our port min var object. So this contains already your your asset name, your constraints, and your objectives. So we're now ready to optimize our portfolio. So to optimize our portfolio means to come up with the best or the most optimal weight for our assets. So the command is optimize that portfolio. So we're creating an object called min var opt1. Okay, and we're using the set that's it because our method will be randomization, a random method. So it will generate random weights. Okay. So port 1 is the name of our asset. Okay, remember port 1 contains Google and Apple. Our portfolio is port min var 1. So this contains the constraints, the objectives, etc. Then the method we're going to use is random. That's why we're setting that seed so that we have the same results. So let's run this. Okay, so the R has now come up with an optimization model. Okay, so the name of our optimization model is min var opt. Okay, optimize. Okay, let's wait for it to finish. Okay, I hope you're able to follow, guys. So actually, this is more of a review because some of you requested for me to review the process. Okay, thank you so much for that request. Because guys, you never really learn this at once in one sitting. So that's why it was also good for us to have a review of this. Okay, it's still running. It's still running. Okay, still running. Okay. Okay, so to save on time, while we're waiting for it to run, why don't we download stock prices? Okay, so this might take a few minutes. Okay, so some of you, if not most of you, know already how to download stock prices from Yahoo Finance. So let's just get stock prices from Yahoo Finance, and the way to go about it is, of course, in R you just use quant mode. Okay. So my internet is again acting up. Okay. It's hanging time again. Okay. So hanging time, and then it's processing very slowly. How about you? Did you run this, guys? And have you been able to get the results?
Warning po.
Running pa rin? Sister?
Warning.
What's the warning?
Oh, wait a moment. Warning, executing percent to par sequentially. No parallel register.
Oh,
I
really?
don't know.
May I
Yes,
see that? May I see that, please?
yes po.
I'll pause share. stop share. And then could you kindly share your screen?
Yes. This one. This one.
Morning, executive, do par, no parallel back and register. Okay,
Yes.
so let's see. So let's see. Mean bar opt one, you already have that. Okay. R is equal to port one, port mean var one. Okay. Optimize. Wait. Sister, could you go up, please? You already run mean var opt, right?
Yes, po.
Port mean var. Could you kindly run that 387 chunk, please? 387. 387. 387.
So different with you, I think.
387 there.
This one?
Yeah. Could you please run that?
Yes.
Okay. So that's port mean var. Okay, so let's continue.
Yes.
Okay, go down. Oh, wait. I'm wondering why are there X's there? Okay. It's okay. All right, go down. Okay. And could you kindly rerun that 417? There.
417. This
Yeah,
one?
that one, that whole code chunk there.
And so now this one?
Yeah, could you run the whole code chunk there?
Time again.
Yeah, so let's just wait for it.
Yes. Yeah.
Min var opt. Okay, so could you kindly click min var opt in the global environment? Or could you type view?
Global import.
Yeah, that one.
This
You can-
one?
There, the first object there, the min var opt. MIN, go up, that's alphabetical. Min, go down. Min var opt.
Min var.
No, it's
This
sorry.
one?
It's for in 425. It's in row 425. Line
This
425.
one?
No, line 425. Yeah, okay.
420.
Yeah, that's it. That's it. You have already the min var.
Yes,
Opt.
I have already.
Yeah, okay. And then run names 426.
This one?
426.
426. This
There.
one?
There. Please
Okay.
run that. Control enter.
Oh, only control enter. Yes.
Yeah, it run, right?
Yes, this one.
Yeah,
Just
so it's already run.
only before this one, but now just. But it's okay. I don't know. Okay,
Yeah,
thank you.
It's okay now. It's okay now.
Yes,
Okay,
okay.
thank you, sister.
Thank you, sir.
Okay. All right. So what has happened? We have we created an object called min var opt1, and it's our first output of optimized portfolio. Okay, so already run in my case, and then here we have okay, let me run min var opt. So why did this run again? Library. Okay, this one. All right, so these are the contents of our min var opt. You have the weights. Okay, so this is more content, guys, compared to the min var, the other list that we created. This contains the weight. Okay, so that's 32% for Apple, 67% for Google. Okay, and then this contains also the objective measure. It's a measure of the standard deviation. Then the what's inside these optimal values, standard deviation. Okay, and then call is the formula. Okay, and then portfolio. So this is the spec. Okay, so this is now it contains many items. Some are, it contains the output, guys, of our optimization. And so we can access some information about that. We can access the weights, okay, the portfolio, etc. Data summary. All right. So what we're going to do now is to so easily we can extract the weights. Okay, we can use the function extract weights, or we can also identify the object. It's min var opt1 and then get the weights. So we know the answer here. This is 32% and 67. 32% for Apple and 67% for Google. Okay, then for the objective measures, we can also use these two codes. Okay, objective measures. Since this is a risk minimization portfolio, then it will give us the measure for the risk standard deviation. It's 1.6%, but that's daily standard deviation. We can compute for the annualized standard deviation. Okay, so here you can plot the weights. Okay, let's just use this. It's the same, only this has some formatting with it. It has a name, okay, the title, and it has specific colors. You can research on this, different colors, using Color Brewer, BREWER. Okay, the legend on the top right. Okay, and then some formatting here. Okay, you can read more on how to format plots in what to say, in R. Okay. All right, then while waiting for the plot. Okay, so it just tells us 32 and 67. So there's no rebalancing here. Okay, so what we're going to do is we're going to generate the returns of our portfolio. Take note here, we had portfolio returns. This is the one with what's this? And this is the portfolio rebalancing. Remember a while ago, we placed this side by side. Okay, so we're going to create also a portfolio with the returns based on the weights. So this one, we'll call it min var perform 1 Okay, I think let's rename this because let's also make this I don't like the name. It's ret min var. Let's just call it minimum variance ret, just to be consistent. Min var ret, minimum variance ret, just like this. Port one ret. Min var, let's call it min var 1 ret. Okay, just like this. Okay, so we're going to ask R from performance analytics to compute for the return of the portfolio. Control C, we call it min var 1 ret. It's more intuitive because of the name ret. Control V. Okay, and then what will be the weights? The weights will be to be extracted from the optimization output that we have. So let's run this. And just like this one, guys, we'll have a data frame of returns. Okay, the weights for one or more periods do not sum up to one. It's okay because we did not use full investments. Okay, so there we relaxed it a bit. Okay, so we now have this object min var 1 ret. Okay, we can change the name. We can change the column name. Okay, so we have to change this. Min var, Control C, Control V, min var ret. Okay, we'll just call it min var 1, just the same. Okay. All right. Okay, let's hurry on, guys. So for the charts, okay, this will give us the weights. Okay. Okay, we can see here the cumulative sum. Okay, these are the daily returns. Okay, and the drawdown. All right, so what else is here? Okay, this one, guys, I'm having problems with this. This would have been a good chart. Okay, but because it wasn't running, I have problems with this one. Once I am able to decipher this, I'm going to message you because we can use this for your paper, for your project. Okay, also this is required, guys, the efficient frontier. Okay, you have to plot the efficient frontier. Okay, which means that you have to do a little research on how to plot the efficient frontier in R. I'm going to teach you. I'm going to show you how to create the efficient frontier in Excel in a while. Okay, now this time it's still minimum variance, but min var opt1, but with rebalancing. Okay, so this one optimized that portfolio, that rebalancing. So that's the difference between the previous one. So the object is port 1. So remember, this is Apple and Google. Then the spec is port min var 1. The method is random. Okay, then we have here some other requirements for rebalancing. What's important here is the rebalance on quarter. So this is quarterly rebalancing. And then the rolling window, so it will compute the standard deviation for around 2 months. Okay. That's what we mean by rolling window for 60 days. Okay, so let's just run this. So this is now with rebalancing. And then we have also, we can extract the weights. Okay, and then let's change this name into min var 1, min var 1, and then ret, then rebal. Just change the name. The other one was min var 1. Okay, where's that? Min var 1 ret. This is min var 1 ret, and then rebalance. So I'm just changing the name here, guys, for it to be more consistent with the others. Where's that? Okay, so I think it's already run. Okay. So what are the weights here? So let's extract the weights. So this one, the weights will be different. Okay, so you notice that every quarter, the weights keep on changing. This is similar to the rebalancing a while ago. Whereas the other minimum variance that we modeled has uniform weight, 0.32 and 0.67. This one will keep on changing its weight on a quarterly basis. Okay. And then based on this, we can now create the returns. So we can also plot the charts for this. Unlike the min var guys class where you only have one box chart, here you have the combination of Apple and Google. Okay, as you can see here, the weighting changes across time. Okay, at the onset, a bigger percentage to Google, but here towards this period, March, September, you can see here that the black Apple had more weight than Google. Okay, here at this particular time, a big chunk went to Apple, a small chunk went to Google until it finally, at the end of the period, reached here. Okay, so you can see here that for rebalancing, there's a change in weight. So let's compute for the return, just like this one. Okay, so let's have min var 1 return rebalance. Okay, so let's also call this. Let's just change the name. Okay, so let's run this. Okay, so here we go, guys. It's the return for. Now notice, guys, the returns was computed starting April. Okay, it was computed starting April. Okay, and why is that so? Unlike the others where the returns was computed starting January. Why do you think was that so? April 3. This one is April 3. It's because of the rolling window. Okay, so you have to first roll out 60 trading days, 60 trading days, and come up with the computation for that, for the return. So there's a way by which they compute for that. Okay, so the difference here is that mean var, the rebalancing has a different start of the computation of the returns because of the rolling window here. Okay, so the chat. Okay, I won't run that anymore. Okay, so what we're going to do is we're going to what's this? Okay, here we're going to compare the two, the minimum variance. Okay, I already changed this name. Control C, Control V. Okay, and then this one I changed the name, Control V. We call it already mean var1 return, and this one Control V. Okay, let's call this all min var, all min var return. Control C. Okay, so I just adjusted the names, guys, and let's compare the by plot. So not so much difference, no? I can hardly see the distinction between the cumulative returns. For the first optimal portfolio without rebalancing. Okay, now I can't seem to see. Can you see the red plot, guys?
No, sir.
I don't seem to see the red one. So is it because it started on April, but there should be one here in April. Okay, so something's wrong with this one. Mean var one. Okay, but we gave the correct name, right? Mean var one. Oh wait. Mean var one. Okay, so it's the same. That's why. It should be mean var one ret, mean var one ret rebalance. Okay. So my mistake. I'm sorry. So let's run this. Okay. Where are we now? Okay, so let's let me plot this. Okay, yeah, there. Okay, so you can see that the one with the rebalancing performed way better than the one without rebalancing. What happened a while ago was that I was combining the same objects. Okay, so you can see here the red one. This is the one with rebalancing, and it really outperformed the one without rebalancing. Okay, and let's just finish this first, and then can we have a 10-minute break, guys? Is that okay with you?
Yes.
Okay. So after we have a 10-minute break, then may I request that we I'll be requesting for a bit of an extension up to 9:15. Will that be okay? Hello, guys. Are you still with me?
I'm okay.
Please don't get mad at me, please. Okay.
Yes, sir.
All right. Thank you. Thank you. Okay. So, so we already plotted. Okay. So wait. Okay. So let's put all of them together. Okay. So let's create this object. Here we call it mode 4. So this is the first returns, the 50-50. This is the 50-50 returns with rebalancing. And then we already renamed this min var 1 ret. So this is the one with optimization without rebalancing. And then we also have min var 1 returns with rebalancing. Okay. So let's plot the comparison of the four portfolio returns. And you can see here, guys, that the min var 1, okay, the min var 1 outperformed, min var 1 with rebalancing outperformed the others. Okay, the blue one here, this is the minimum variance with rebalancing. All right, and then let's also okay, let's combine all of them. Okay, so this one I'm just adding it here. Okay, adjust for all the four returns. We're going to add all of them. Kindly insert this. Okay, so let's call it all the portfolio. So we're going to combine. Okay, C column bind port 1 ret, port 1 return rebalance. We also have min var 1 ret. Easier to remember this name. Min var 1 ret, and also this one min var 1 ret rebal. Okay, min var 1 ret, min var 1 ret rebalance. So these are the four four objects, guys. This is the 50-50 portfolio. This is the 50-50 with rebalancing. Okay, of course, it changed later on. This is the optimization without rebalancing. This is the optimization with rebalancing. Okay, now if you run this head of the all port, you'll notice that for the min var ret rebalancing, for the first 3 months, it has an A. No? It does not have any return because of the rolling calculation. Okay, so but anyway, let's just let's change the column names of all port. So we have non-rebalanced, monthly rebalanced, min var ret, and the other one is min var ret returns with rebalance. Okay. So we have this object, the all port, which contains all the returns that we calculated so far. Okay, and then let's compute for the table annualized return of all port. Okay, and then we're going to use also the risk-free rate at 10% per annum. So when we run this, okay, we're going to see which of them performed best. Okay, I'm sorry, I run the so let me just run the table of annualized return. There. Okay, let's see, guys. In terms of annualized return, okay, it was okay. The monthly rebalance seems to be the best performer. Okay, so the optimization, guys, performed less. You know why? Because the objective here was more on minimizing the risk. Okay, for the standard deviation, the lowest was this one. Okay, the minimum variance. Okay, the minimum variance without rebalancing. Okay, so the best performer in as far as Sharpe ratio is concerned, risk per unit return, turns out that the monthly rebalancing without the optimization was even the better performer compared to this one. This two with the this two with the optimization. Okay. So in fact, this was the first in terms of Sharpe ratio. This is second. The ones where we did not optimize were the ones that had the higher Sharpe ratio. Okay. All right. Let's pause there for a while. When we come back, this will be faster because it's just repeating the process, but this time we'll be maximizing our returns. Okay. All right. So it's 8:15 by my watch. Let's be back around 8:25 just to have a water break because I know this is really very brain damaging. Okay, guys. I'll see you in a while, in 10 minutes. Let me pause recording first. Kindly remind me, guys, that I pause recording. So first, what we're going to do is I'm going to illustrate how to create and the efficient frontier and how it looks like. So I'm sure you went through this developmental theories of finance, and one of the most important topics there is the modern portfolio theory by Harry Markowitz, who incidentally won the Nobel Prize for this. And it specifically tells us that you can minimize the risk by creating a portfolio, increasing stocks to your portfolio. So let me illustrate that. Finance, you can go to, let me just show you how you can download, quickly you can download stock prices in Yahoo Finance. Of course, we have learned how to do this in R. But let me just illustrate very quickly how you can do this. So let me show you first. Kindly open, by the way, the Excel file that I shared with you. Okay, so you go through finance.yahoo.
Just screen share po.
Oh, sorry. Okay, so I opened finance.yahoo.com and you have to know the ticker symbol. For example, if you want to download Apple prices, AAPL, so this is downloading without the use of R. Okay, so let's search for that. AAPL, this is the ticker symbol for Apple. Okay, here, AAPL. So let's click this, and then it will give us, it will bring us to the to information about Apple. Okay, so this is the currency. It went down by $2.94 or a drop in 1.67%. So there are lots and lots of information here. The beta of Apple for the past, Yahoo Finance computes the beta based on a 5-year monthly monthly returns, then compare it with Standard & Poor's, it's 1.19. This is indicative of the sensitivity of Apple stock relative to the market, which is Standard & Poor's. Okay, so we can get the historical data, you get it here. And then you can specify the range, the date, and then you can just download the historical prices or dividends only or stock splits or capital gain. And then you can choose the frequency, whether daily, weekly, or monthly. And then you can download this. So that's how you download stock prices from Yahoo Finance. Now I shared with you an Excel file. So what I did was I already downloaded the stock prices so that we save on time. Okay, so where's that? Okay. Let me open that. Okay, here. Apple, Facebook, and
Sir,
Tesla.
sorry.
Yes?
Which specific tab from Yahoo Finance again? I wasn't able to catch that.
Sorry. Which
Uh,
specific?
Which specific tab in Yahoo Finance can we download it?
Okay. So here, historical data.
I see. Okay.
Okay, you go to historical data, and then it will bring you to this site. There. Okay. So you identify the period from what date to what date. Okay, you can identify it here. And then you can download either dividends only, stock splits, capital gains, or the historical prices. You can also choose the frequency. Okay, and then apply it first, guys. Apply the changes that you made here, apply, and then download. And then it will give you a CSV file. Okay, so I shared with you, an Excel file. Where's that? Okay, Apple, Facebook, and Tesla. I downloaded these three prices. These are weekly data. Okay, weekly data. I think my computer is really very, very slow. Okay, so these are the prices. So I downloaded weekly. I chose weekly from December 1, 2018 until December 31, 2021. So these are the trading dates. Okay, so our objective is to create an efficient frontier. Okay, the efficient frontier, according to the a modern portfolio theory of finance, is that curve and consisting of the combination of assets which will either give you the highest return for a given risk or the lowest risk for a particular return. Okay, so let's do that. It's called the efficient frontier. And since you told me that you have not created that before, so let me teach you how to do that in Excel. Okay, so I think we will budget around 15 minutes for this. So first, let's copy the name of the stocks and put it here. Okay, because we're going to get the returns. Let's use log returns. So ln, okay, in Excel, so log returns is equal to the price at time t divided by the price at time t minus 1. Okay, so that's just the log returns. So we can copy this and then drag this down. There. Okay, so we now have the log returns, daily log returns. Okay. All right, so take note, these are daily log returns. Okay, so we will compute for the, okay, we will need first, okay, so let's do that. Let's copy this again. Okay, here. And then let's compute for the annual Annual returns, and the variance, and then the standard deviation. You can compute these ones for the individual assets first. So for Apple, for Facebook, and for Tesla. Okay, so how do we compute for the annual returns? Okay, all of this should be annualized, guys. So let me just put it here. Annual annual statistics. So this is, I'll just remove the annual there. Oops. So annual statistics. Okay, so let's compute for the average return, the variance, and the standard deviation. So for Apple, we're just getting the average of the weekly returns. Okay, this one, Control Shift down arrow, Control backspace, there. Average of F4 up to F211. However, guys, these are weekly prices. So how do we convert this into annualized return? We multiply this by 52. Okay, so this will make it annualized. Okay, strictly speaking, it should be the average, and then you raise it to the 52 and then -1. That should be the strict formula because you're continuously compounding. And I hope you got that already from your previous subjects. Okay, so this is now annualized. Okay, let's just convert this into percentage. Let's make it 3 decimal places. Okay, so the average of Apple for the past, this is 4 years, 2018, 2019, 2020, 2021. Past 4 years weekly data, it was 36.224. So we can copy this down to the right. So Tesla had the highest average log returns for the past 4 years, from January 1, 2018 up to December 2021. Okay, how about the variance? The variance, we just use the var.s, variance sample. Okay, again, we highlight the returns. Take note, guys, we're getting the descriptive statistics on the returns and not on the prices. Usually when we're modeling in finance, whether it's time series or either ARIMA modeling or GARCH modeling, we use the returns. Okay, and the variance, in order to convert it to annual returns, it should also be multiplied by 52. There are 52 weeks in a year. So let's just copy the format of this and copy to the right. Okay, so we can see that the riskiest asset is Tesla, and that's understandable by virtue of the principle of risk and return. Okay, so, and then the standard deviation. The standard deviation will be, it can just be the square root of the variance, or let's use the formula, square root. It has to be the square root of 52, guys. Okay, square root of 52, multiply that by the STDEV, the standard deviation formula in Excel. That's STDEV-S. Okay, and then Apple. Backspace. All right. So this is the formula for the standard deviation. Okay. Control Enter, and then let's copy the format here. Okay, let's just check, guys, if this is the square root of the variance. Let's see if it will give us the correct answer. Yeah, same, 65.188. 65.188. Okay, let me pause for a while. Let me give you a breathing room. I'll also share this file with you if you want, so that you can review your work in case you miss out on some of the formulas. Okay, clear so far, guys? Clear so far?
Clear so far.
Okay, so we have the average returns of Apple. These are now annualized, no? Average return of Apple, Facebook, and Tesla, their annual variance, and the standard deviation. Now, when we're doing portfolio analysis, okay, let me just access my digital pen. We need the variance covariance. I don't know if in your subject, did you encounter how to compute for the portfolio standard deviation, portfolio risk? Have you? Guys, have you encountered that? How do you compute for portfolio risk? So if not, guys, let me just quickly, okay, I'll quickly write it here. So let me access my digital pen review. Okay, the portfolio return, in order to compute for the return, that's very easy. What happened to my digital pen? Okay. Oops. It's not connected. Okay. Okay, this is just a review. I'm sure you have met this in your other subjects, particular portfolio management. So the return of your portfolio, let's call it R sub B, is just equal to the weighted return of each of your asset. So it's just the weight of, let's say, Apple multiplied by the return of Apple, and then just sum all your assets in your portfolio. Now, the more difficult one is your variance or the risk. So the risk is measured by, okay, I won't anymore explain this, but it's actually double summation, okay, of your weight sub I, weight sub J, and then the covariance of the return of I and the return of J, okay, or IJ. So that's your your portfolio variance. Of course, for the risk, you'll just get the square root of that. And this can be transformed mathematically into weight matrix multiplied by the variance covariance matrix multiplied by the weight transpose matrix. Okay, so that's how you compute for your portfolio variance using this formula. Now, this may be a very involved formula, but in Excel, that's very easy. So we need first to compute for our variance covariance. So let's do that. Now, data. Okay, data. Please go to data, and then do you see here data analysis? Have you used data analysis before? Could you kindly give me feedback, guys, if you have data analysis there?
No, sir. Not
No?
yet, sir.
Okay, so if not, then I'll teach you how to. You need also to install both data analysis and solver. Okay? So we go here to file. Anyone using Mac here?
Me, sir.
Medyo iba kasi sa Mac, no? I love. Okay, so sorry, hindi ko kabisado yung ano sa Mac interface.
Okay lang.
Okay, I think ano ba yung sa how do you install data analysis? Okay, I'm sure you'll be able to find that.
Sir.
So file, options, no? Maybe under options, may taba na options done. File options for those using Windows, and then add-ins. And then under add-ins, guys, you'll see this Excel add-ins. Go here, and then you'll have to click Analysis Toolpack and Solver. So these two, Analysis Toolpack and then Solver. Okay. So when we click OK, then we'll have it here, data analysis and solver. Okay. So let's first use data analysis. There are lots of statistical processes that you can do here. So let's click data analysis. So you have here ANOVA, correlation, covariance, ES, exponential smoothing, Fourier analysis, histogram, etc., regression, t-test. Okay, so a lot of statistical processes you can do here, but we're interested in the covariance. Okay, so covariance. So we will have to highlight the returns Apple until all the including the labels, and then it's grouped in columns, and then we put your labels in first row there. And the output range, let's click this output range. Let's put it somewhere here. Let's put it in here. I'm putting it here in J10, or maybe here in KJ9. Okay, J10. I think I need 2 spaces. Okay, and then this is ready. All right. Okay. So this guys is the. Okay. What happened? Oh, sorry. Wrong, guys. Wrong. What I accessed was the prices. No? So it's not the prices. It's the. So it should be here. F. Should be the returns. Okay. Sorry about that. Please change it. It should be the returns. We're modeling the returns and not the prices. Okay. I was surprised because they're big numbers. Okay, wait. Okay, so this is it, guys. Okay, this is your variance covariance. So this is your weekly var cover. So the diagonals here are the variances because you're pairing Apple with Apple. Okay, Facebook with Facebook, Tesla with Tesla. So the other non-diagonals are simply the mirror images. These are the covariances. So the covariance of Facebook with Apple is just the same as the covariance of Apple with Facebook. So since they're mirror images, we'll just copy it here. And then Tesla and Apple will be the same here. And then this one will be the same here. Okay. So we now have a complete variance covariance. Okay. Now, what we need is, let me just move all of this down. Okay. Now, what we need is the annual variance covariance. Okay. So not the weekly. So let's just compute for the annual variance covariance. That's what we need. So let's copy this, guys. Let's copy this. Control C, and then just paste values. Okay. Just paste the values. Okay. Okay, and let's convert this into percent. Okay, these are weekly. So what's the best way to quickly convert this into annual? So we multiply it by 52, right? Okay, we multiply it by 52. So how do we multiply everything by 52? So quick way to do this in Excel, you write 52 and then Control C, copy, and then you highlight your variance covariance, and then highlight, and then right click, paste special, and then multiply. Okay, so we can multiply 52 to all of the numbers here. Okay, there, make it percent. Okay, and if we compare this, guys, 8.9926, this is 8.97. So a little difference because of rounding off. 8.97. This is 11.133, so a little difference, okay? Okay, because we copy pasted this here. Okay, but what we copy pasted was not only that number. It's a longer number. Okay. Okay. Or maybe what could have worked was. Okay. Anyway, never mind. All right. So we now have the variance covariance. So let's now construct a portfolio. Okay, so first we have the weights. So when we construct a portfolio, we should have the weights, and the sum of this, we're going to set it to be equal to 100%. Okay. So these are the weights. And then we'll compute for the portfolio returns, the portfolio risk. Okay, so how do we compute for the portfolio returns? We follow the formula, this one. It's just a summation of the weights and the returns, right? So this is the returns of Apple, okay? Ito yung returns ni Apple, Facebook, and Tesla. So the weights, we're going to multiply by the returns here. Okay, so let's do this. Let's first assume that it's equally weighted. So 1/3 equal to 1/3, then equal to 1/3. Okay, time flies so fast. Okay, so the returns will be equal to, we can use the sum product, sum product in Excel. So that means we take the products, this one times this one, this one times this one, this one times this one, and then get their sums. Okay, so sum product of the weights, comma, and then your returns. Okay, so the returns for this, for your equally weighted portfolio, okay, it's 40.73. So if we compare it with the returns here, okay, it's lower than your Tesla returns, okay, but it's higher than your Apple and your Facebook. So that's what happens when you create a portfolio. It will be low. The returns will be lower than the highest asset with the highest return, but it will be higher than the others. No? So our portfolio, which is equally weighted, 1/3, 1/3, 1/3, has a return of 40.73. Now for the let's say more difficult part. So how do we compute for the portfolio risk? Okay, so we have to apply this. Now this is a very lengthy formula, but the shortcut in Excel is just, let me first show you. So this is equal to, first in Excel you get the matrix multiplication. Remember, this is matrix multiplication, this one. So we're multiplying the weights, the weights, comma, and the variance covariance, which is this one. Okay, so let's fix the variance covariance so that we can copy this formula. And then let's close this. Okay, and then pre-multiply the sum product. Unfortunately, I don't have the time to explain why that is so. Okay, and pre-multiply the M-mult with the weights again. There. But it can be easily explained. Okay, so this one is the same as this one. And then we get the square root because we're looking for the standard deviation. Square root. Okay. And then since this is a matrix, what you press is Control Shift Enter. There. So the risk, let's make it percentage. Let's copy this format. The risk is 33.93 for this portfolio. And if we compare the standard deviation, okay, so it's the standard deviation, the riskiness is higher than, this is Apple, but lower than Tesla, and lower than, higher than Facebook. Okay. Of course, we want a portfolio that's lowest than any of this. And the reason why we're having a portfolio risk that's higher than some of the assets here is because we're just guessing the weight. We know that we can change this. Okay, we can change this weight into, let's say, 20, 30, 40, 20, etc. And then you'll be able to come up with a portfolio that's lower than the risk of here, than the risk of Apple. Okay, so what we're going to do now is we're going to create many portfolios. So let's copy this. Control C, I'm going to copy it here. There. Okay, so this is the tricky part. Okay, so we're going to create several weights. Okay, several weights. So let me delete this. Okay, the formula is still the same. Okay, sum product of the weights multiplied by the returns, and then this one is still the same. So it's the M mult of the weights, and then the variance covariance, and then the weights. Then I have to press Control Shift Enter. Control Shift Enter. Okay, I know, guys, that I'm going too fast, but anyway, we will have this recording. I'm going to post it, and then you can follow along. Okay, so I'm sorry I cannot at the moment be slow, because we have to finish this, because this will guide you guys in your project. So how do we now create the weights? Now I'm going to create some random weights. This is a technique which we can do. Random. A random. Okay, so in Excel you have the rand function is equal to rand. The rand function will give us numbers between 0 and 1. Okay, so that one, 0.9173, etc. And then if I press F9, I'm pressing now F9, you notice that it's changing. It's changing every time. Okay, it's recalculating. So how do we now use this to be the weights of our assets? Okay, we can sum this. Let's get the sum of this random numbers, random weights. And then in order to convert them into our weights for our portfolio, what we can do is divide the random number by the sum of the random number. Fix this. By doing that, okay, and copying this to the right, you notice that the sum will always be 1. Okay, because we normalize the data by dividing everything by the total. So if I press F9, you notice that the weights are changing. So this will represent the weight for Apple, for Facebook, and for Tesla, and the total weight is 100%. So this will be different weights, and then we'll have different computations. Okay, so I think this should be the weights. Okay, this is wrong. We should have, I didn't fix the return here. Okay, this one should be the returns. Okay, the returns are this one. Okay, I'm sorry about that. Okay, so let's run again, F9. I'm pressing F9. So you see there are different returns, there are different risks, okay? And it's based on the changing random numbers. And the random numbers always add up to 100%. Okay, so what we're going to do is, let's copy this here. I'm going to transfer this here on top. Okay, here. And then I'm going to use this to create several portfolios. Okay, so here I'm going to say trials, and then portfolio risk. We'll start with the risk because that's the x-axis, and then portfolio return. Okay, so we will link our portfolio risk to this one. This is our portfolio risk, and this is our portfolio return. There. So every time we press F9, the risk and the return changes, and it copies. All right. So we will create, let's say, 10,000 portfolios. Okay, that's a lot. Okay, 10,000 portfolios. So how do we do that? I start with one here. I start with one, and then I'm going to fill a series. So fill here under editing, fill, and then series. Okay, the series is in columns. It will be going down. Okay, step value is I'm going to ask Excel to generate 1 unit increase, 1, 2, 3, 4, 5 until 10,000. Okay. 10,000. So this will generate an array in columns from 1 to 10,000. Take a look at that there. Okay, 1 up to 10,000. So we have now 10,000 trials. So we're going to ask Excel to run this 10,000 times and then come up with the portfolio risk and portfolio return. So let's highlight this. Highlight everything until 10,000. There. I highlight everything, trials, here the risk and here the return. And then I'm going to use data, what if analysis, then data table, okay? And then the input, it's in columns. I'm going to click here, click in the input cell, and then click anywhere here, anywhere outside this. There, okay. Okay, so now guys, you have, so let me copy this format, okay, home, format, okay. So I copy the format in decimal place. Okay, so what do you notice guys? If I press F9, okay, there, you'll have 10,000 different returns and different risks. Okay, so it's based on our returns and our variance covariance. So we're now ready to plot this. So I'll highlight everything. Okay, highlight everything. I'm sorry guys, I have to do this because we're really out of time. Highlight everything guys. Anyway, you can view this again. Insert, insert, and then I'm going to insert a plot. Okay, the plot is this one. Scatter plot there. Okay, looks like we're having a, we now have our efficient frontier. Okay, so let me just revise this a bit. Change the format so that it looks better. This is the efficient frontier. So let me edit the axis. I'll make it around 25% because it's too far from the y-axis. Right click, format axis, and I'll make it closer. Say 25, maybe 25%. Okay, I think, or maybe 24. Okay, 24, enter. Okay, so I'm now closer here. All right, then I'm going to format this. Click, format data series. I'm going to change the fill, the marker options. Okay, I'll choose the built-in, and then I just use this very small one there. And then size, I'll make it the minimum. Okay, if you can see now, guys. Okay. Okay, and then let me change the design there. There, and then maybe I'll change again the format. Okay, bring back the marker. Okay, marker options built in. that one. Marker built in that one. Okay, 2. Okay, why did it not change again? Let me change it. Format data series. Marker options. Okay, I'm wondering why it did not change. Okay. Should have changed. Marker options. Okay, okay, here built in. Let me renew this. Then just this small line, and then there. All right. Okay, looks better now. Looks good. Okay, so this, guys, is your efficient frontier. Okay, so this is the soul of modern portfolio theory. Okay, it tells us that. Okay, this tells us in this space. Okay, this line here, this is your efficient. This is your efficient frontier, and this point, I'm just guessing. This point, let me highlight that point. Okay, and change the format, maybe put, make it red. Make it red. And then maybe increase the weight. Okay, no, it's not working. Okay, anyway, guys, so this is our efficient frontier, and the one here, guys, the point here is your minimum variance, this point, because that one gives us the least risk, the least variance. Okay, all the points here above the minimum variance are your efficient points. All the points here below the minimum variance is your inefficient points. Now, why is that so? Because, for example, if I choose this, this represents a particular weight, a portfolio. Why will I choose this portfolio that has this risk when I can choose a portfolio that has the same risk, but if I project up here in this line, it has a higher return, okay, and a lower risk. Okay, so I'm going to share this with you guys, and anyway, you have the so that you can follow along with the formula, and then you have the video, so you can replicate this. So that, in a nutshell, guys, is your efficient frontier. So it's one of the landmark theory aspects of modern portfolio theory. This one. So we have learned how to replicate that. Of course, in R you can do that. Okay, so do some research on that, on how to create your efficient frontier. Okay, now for this one, guys, anyway, you'll be able to, I'm sure you'll be able to do this. So here, we're just changing the objective. Okay, we're creating another object here. Naghang na naman yung aking my R. So we're creating another object here. Portfolio mean. Okay, mean and then variance. So this is now, we're now optimizing our returns. Okay, so we once again assign it to port spec 1, and then you see that the objectives that we're adding is 2. We have the risk and then the return. Okay, so if we run this, so we're now creating this port mean variance object. Okay, and then we can now optimize that portfolio. Optimize a portfolio, and then once again, guys, you'll be able to extract the weights. Okay, you'll be able to know which weights, the same thing as we did above. Okay, so kindly please continue with this, because this will form part of your project. You're not only supposed to minimize the variance, you're also supposed to maximize the returns. And then you can also again come up with a with an object that will we'll compare all the six models that we have created here. Okay, the 50-50 portfolio without rebalancing, the 50-50 portfolio with rebalancing, and then the minimum variance with rebalancing, maximum returns, and then maximum returns with rebalancing. Okay, so that takes care, guys, of your portfolio optimization. And again, your project on this will be due 2 weeks from now, Friday, 6 p.m. You have to email it to me. Okay, so with that, guys, thank you so much for let me stop the recording. If you have any questions, please feel free to PM me, message me through Messenger, and I'll gladly entertain your questions.
Sir,
Yes.
can we have copy of the?
Hello, sister, you're still there?
Yes,
Love.
sir.
Okay, I'm sorry. Okay,
Yes.
so you were asking for a copy of the Excel file, right?
Yes, sir. The updated one, sir.
Okay, let me share it now, okay? So that, because I might forget. So I'll just save it now. Okay, so let me save it first.
Yes.
Okay, so that you can have a copy now, immediately.
Yes, sir.
Okay, so let me save it first. File. Apologies, my computer is really very slow. File. Okay, save as. Save as, then I'll save as -1. Okay, I'll put -1 to it. Save. So I have to close it first because I can't send to you in chat box if it's open. Okay, please bear with me because this computer is really it's senior citizen. Takes long to open, takes long to close.
Also, my computer, my laptop. So
Okay,
my
so while waiting, guys,
stress.
I call my computer as a senior citizen computer. Okay, I hope you learned something, guys, in the term that it was a journey, it was a joy journeying with you. Thank you so much. I hope our time was really worthwhile. You learned something. Okay, wait.
Yes, thank you.
Thank you, sister. Thank you, love.
Thank you, sir.
Thank you, Ronnie. Thank you. So when are you going to have your thesis?
Next term,
Next
perhaps.
term? Wow.
Yes, hopefully.
Wow, that's very good. It's very good. Okay, I wish the best. Okay, God bless on your journey.
Thank you. Thank you. Amen, amen, amen.
Amen, amen, amen. It's okay. Okay. End process. Okay. Okay. Let me share it with you now. Good thing it closed. So no, it should be here. It should be in the chat, right? Chat. Okay, just a minute. So first time for you to create an efficient frontier.
Yes, sir.
Okay, you just press F9 if you want to recalculate. Okay, for the rand function. Okay, it's now loading.
Still waiting.
Loading. Okay. All right, there you go, guys. So kindly download that, and you may wish to look at that again. Okay, so once again, guys, thank you so much. It has been a wonderful term learning
Thank
with you, journeying
you.
with you. Okay, I hope to meet you soon in the campus. Okay,
Amen.
amen. Okay, Ronnie, thank you. Robbie, thank you.
Because
Love,
this
thank
struggle
you.
time.
Sorry?
Struggle time because of pandemic.
Yeah, that's true. Okay. All right. So thank you so much, guys.
Thank
Please
you.
feel free to PM me to
Yes.
just message me if you have any
If
concerns.
we need to some
Sir.
Yeah. Okay. Sure. Sure.
Yeah. Thank you,
Okay.
sir.
Thank you, guys. I enjoyed our sessions. I enjoyed learning with you in this journey. Thank you so much.
Yeah. Keep safe and
Okay.
stay healthy.
Okay. Thank you. Bye bye.
Bye-bye.
Bye bye.
Bye bye.